Hello, ladies and gentlemen. Today we're going to talk about the triangle congruence theorems. I know we briefly talked about it a little bit already, but now we're going to fill out our foldable. You're going to need your notes, a calculator, something to write with, and again, something to write with, and again, you're going to need that foldable I handed out in class. So the first thing we're going to talk about is side, side, side. So when I write S, 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 okay, we talked a little bit about this when we talked about Billy Bob's, but can we prove these triangles congruent? If I have three sides the same in two triangles, can we prove them congruent? The answer is yes. If you have three pairs of congruent sides, we call this the SSS congruence postulate, where all of the S's stand for the word side. So why don't you take a second, get this written down in your notes, and we'll move on to an example. So an example of a problem that I might give you on your worksheet is here are two triangles, and I want you to prove the triangles are congruent using the theorem SSS. Again, S just stands for side. So this would be side, side, side with three congruent sides. So what it says is state what additional information is needed in order to use the given postulate. So if you look at the triangles we already have, it shows us that RS is congruent to XY. Okay, we also know that GS is congruent to ZY. So in order for this to be SSS, that means I would have to have all three sides congruent. So the additional information I would need is to show that RT is congruent to XZ. So how would I write this? So I'm going to write RT, this is the side length, so I'm going to put a bar over the top. I'm going to write the congruent symbol. Now, is it important which letter of my other triangle I write first? Hopefully you're thinking yes, because if we look at this one, R would be the angle that is congruent to angle X. So when I start writing that other segment that's congruent to RT, I have to have X in the same place as R. So X is coming first and Z would come second. So this is how I would answer what additional information is needed in order to prove these two triangles are congruent by SSS or side, side, side. So our other example then here, again, we have two triangles that we want to prove congruent by SSS. And remember, that just means three congruent sides. So in this one, they only show us that two sides are congruent. So in order for us to prove this by SSS or side, 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 I would need to know that GX is congruent to YZ. So if I write that again, remember, the angles that are corresponding to each other have to be written at the same time. So if I write DX first, this has to be congruent. Since D is the angle congruent to Y, I have to write it as YX. Oh, YZ, excuse me. YZ. I'll scribble that out. It's supposed to be YZ. Okay, so now I have two sides. Now the last side that they would share, the one that they share. So if you look here, this XZ line is the one that both triangles share. So we would write XZ is congruent to, now remember, since X is this angle up here, but it's the angle Z down here, when I flip it and I write it the other way, it has to be written as ZX for my other triangle, due to the fact that these triangles are kind of flipped upside down in comparison to one another. So in order to prove SSS, I had to show two other sides of the triangles were congruent to each other. The next postulate we have is side angle side. So we would write that as SAS. So if we were thinking back to Billy Bob's, were we able to prove that these two triangles are congruent if they had a side, an angle, and a side congruent to one another? We were able to, so yes, two pairs of congruent sides. Write this down in your tab. Two pairs of congruent side and the included angle. We call this the SAS postulate, congruence postulate. S stands for side, A stands for angle. Now what's important about this one is to show you over here on this diagram, the angle is between the two sides that are congruent. Okay, so in both triangles, the angle that we're talking about is between the two congruent sides. So that's really important as we go forward due to the fact that we have a bunch of different postulates to talk about. So another example we have here is, here we're given two triangles. What additional information do we need in order to prove SAS, or side, angle, side? So what's important about this, since the A is between the S's, that means the angle needs to be between the sides. So if you look at this picture, what two sides? I have one side congruent and I have an angle. So what are the other sides I would need to know are congruent in order to prove these two triangles are congruent by SAS? I hope we're thinking that these other sides that make up my angle, okay, so now the two sides that I have congruent would be the ones that include the angle that is 90 degrees. So in order to write this, I would write WU is congruent to ZX. That's the other piece of information I would need in order to prove these triangles congruent. So this example is just a little bit different in the fact that we aren't given an angle, but we can figure out what angles are congruent using old information. Okay, if you look here on this diagram, we have this angle right here and this angle right here. Those two angles are congruent, but why do I know they're congruent? Because they are vertical angles. And remember, vertical angles are congruent. Okay, so now I have an angle congruent and I have a side congruent, but I need to make sure that the angle is between the two sides. So in order to prove SAS, the other side lengths I would need to be congruent are DS and TS. So I would write DS, and remember the D is congruent to the T, so those two have to come first. So then the other one would be TS. And that's how I would prove these two triangles are congruent by the postulate SAS. The third one we have would be angle side angle, and this one's exactly opposite of the one we just talked about because this is ASA. And if you think back to Billy Bob's, can we prove the triangles are congruent if two angles are congruent and the side between them are congruent? The answer is yes. Two pairs of congruent angles and the included side means that we would have the ASA congruence postulate. So this one's a little bit different because now instead of the two sides and the included angle, I have two angles and the included side. So make that a note. When the S is between the two A's, it's angle, side, angle. And so the side is between the two angles that are congruent. The fourth one we have is hypotenuse leg, or HL. And if you think back to our Billy Bob's activity, were we able to prove these triangles congruent? We were able to prove these triangles congruent, but notice here that this is a right angle. So the only time we can use hypotenuse leg is if we have a right triangle. Okay, and the hypotenuse, what is the definition of the hypotenuse? Well, the hypotenuse, I hope we're remembering back, the hypotenuse is the side across from the 90-degree angle. Okay, so hypotenuse, leg, and a leg would be one of the sides that makes up your 90-degree angle. So HL, again, is another congruence postulate that we will use, but we can only use HL when we have right triangles. The next postulate we're going to talk about is angle, angle, side. So this is going to be written as AAS. Okay, so now the side is on the outside of my angles. And if you think back, can we prove these triangles congruent? Yes, we can. So if we have two pairs of congruent angles and a non-included side, we know that they are congruent by AAS. So again, this one's different because my angles here are congruent, but the side that's congruent is outside of the angles that are congruent. So remember, since S is not in the middle, we're not including the side between the two angles. The next theorem we have would be angle, side, side, or the way that it's written in your notes would be side, side, angle. So if I were to write that out, side, side, angle, this means I'd have one angle and the two sides that don't include the angle would be congruent. So if you look at these two triangles, they clearly don't look congruent. So by SSA, we cannot prove triangles are congruent. So let's get that written down. No, these triangles would not be congruent. If we were to flip this and put the A in the front, we'd notice it would say a bad word. So that would be, if we have a bad word, we know that it cannot be congruent. So make a mental note of that. It's a bad word, so we can't prove congruency. And lastly, we have angle, angle, angle. So this is A. And you think back to Billy Bob's, we had all triangles of all different shapes and sizes. So can we prove these triangles congruent? No, we may not. We can't prove they're congruent, but we can prove similarity, which is something we'll get to in the next couple of chapters. So know that they are not congruent, but they are similar. So when we talk about the two that don't work, two postulates that don't work, this is AAA, and SSA. So bad words and car insurance. You can't have bad or car insurance. Make a mental note of that. I want to thank you for taking good notes, and I will see you when I see you.